Well, good afternoon, and welcome to Replicating RDB Databases to Oracle 23 AI in the Cloud. My name is Keith Hare, and I worked on this presentation with my colleagues Tom Musson and Cheryl Jobert. So the JCC LogMiner Loader is a utility from JCC Consulting that replicates committed transactions from an Oracle Rdb database to a variety of targets. In this presentation, I want to go through a step-by-step of setting up the LogMiner Loader and its capabilities to replicate RDB committed transactions to an Oracle 23 AI autonomous database in the Oracle Cloud. I'll also spend a few minutes and provide a brief introduction to using property graph queries on SQL tables in the Oracle database. I want to spend a few minutes on the big picture, go through the details of how you set up the data replication, and then do a quick look at property graph queries. So the JCC LogMiner Loader is a utility to replicate committed transactions. It takes advantage of the RDB continuous log miner RMU unload / after to extract committed data from the RDB database and then replicate it to something else in near real time and transactional consistency. In the target database, there is data store. You could use that for additional reporting, for data analytics, ad hoc queries, all sorts of things. For source, we support RDB, any version that supports the RMU unload / after command. For targets, we'll replicate to RDB, we'll replicate to Oracle using the SQLnet client, which has some limitations. And then if we can get a JDBC class 4 driver for a particular target, we can replicate to that target. We also can publish to intermediate things such as Tuxedo or XML to an API or to a file or to Kafka. The sources and the targets can be completely different. We're replicating to different databases, doing logical data replication. And so the organization, the database can be completely different. This is what the big picture looks like. The blue is RDB. So you've got an RDB database, you've got after image journals. We set up a number of processes, and I'll talk more about these later. But basically, we tell the RMU unload / after the RDB continuous log miner what data to get. RDB writes it to an OpenVMS mailbox. Our code reads it from the OpenVMS mailbox and writes it to another target. So basically, RDB will write the committed transactions to the OpenVMS mailbox. Our software reads from that mailbox and publishes or writes to various targets. To do all of this, there's a bit of setup, so we have control files to configure everything. In this example, for the source database, we're using Oracle Rdb version 7.4-120, running on an Integrity BL860CI2 with a number of CPUs and some amount of memory. And importantly, we're running Java as a JDK 8.0.222B05, if I got all of the letters and numbers correct. The target database I set up in the Oracle Cloud. It's a 23 AI autonomous database with two eCPUs. I disabled auto scaling because I didn't think I needed it for the testing I was going to do. Set it up to use mutual TLS authentication, or actually I set that to not required. I did set up an access control list and set it so that the only entry was from the JCC IPv4 addresses, so that you can't quite take my example here and go replicate to my database. This is what the screen looks like on the Oracle Cloud side. This is more or less just to prove that I was actually there. So we support RDB version 5.0.6.5 or later, which is when the LogMiner capability was added to RDB. There's some prerequisites. You have to have circular journals enabled and continuous LogMiner enabled. And I'll come back to this, but you need to understand the key value to your data, and it can't change. It has to be immutable. In this example, I'm going to use the RDB sample database, which you can create with the SQL sample procedure. And so the data looks like every other example using the RDB sample database. Create some journals. In this case, I'm adding 4 journals, and I left out some of the script, and then altering the database to say that journals are enabled. And at some point, we enable continuous LogMiner, add some information for backups and such. So standard RDB stuff. We'll potentially add VMS functions, which one of our procedures uses for some capability. So I mentioned immutable primary keys. When we update the target, in part of the configuration, you tell us what the primary key is to update the rows in the target. If those values change, then we're not going to be able to find the old version of a row, because we have to do a query to see if a row exists. If it does, we update it. If it doesn't, we insert it. And if the columns you're using for the primary key have changed, then we won't be able to do a one-to-one replication. There's a couple ways to do this. You can add SQL identity columns to the source table as one option. So I created a database. We needed to create some tables. RMU allows you to extract a script and have the data definitions, because we have to have tables to replicate to. There is, for Oracle 23i, there is some editing required because the syntax is a little bit different than RDB, but it's relatively straightforward. The data types are also a little bit different, so you do have to do a little bit of editing for data types. At the back of the presentation, I have a couple of slides with some possible mappings of RDB data types to Oracle data types. There's a couple of ways of accessing the Oracle 23 AI. In this case, excuse me. In this case, I used SQL Plus with the Oracle Instant Client running from my Windows 11 laptop for the examples that I'm going to use. But basically, it allowed me to connect to the 23 AI database in the cloud. With any new database, the question is, how do you figure out what tables exist? How do you figure out what the tables look like? In SQL Plus, I do a query against user tables and use the describe to see what the columns are for a particular table. With the JCC LogMiner Loader, we've ended up bouncing around a whole variety of target databases. And with any database, there's always the question, how do you know what it looks like? How do you know what the tables look like? And that part is different in different databases. To set up a LogMiner Loader session, we have to configure a JDBC driver. The options file tells the RMU_onload/after what data to extract, and then some configuration files that map the source data to the target data. This is a little bit intimidating the first time or two you do it, but it's basically relatively straightforward. And once you've got it figured out, it all works relatively easily, painlessly, and continuously. For the JDBC driver, in this case, I'm using the Oracle JDBC 8 jar file, which I downloaded from an Oracle website. And according to the documentation, this implements the JDBC 4.2 spec and is certified with JDK 8 and JDK 11. And that's important because on VMS at the moment, we only have JDK 8. In this case, I put the driver on a VMS ODS 5 because ODS 5 supports lowercase names. I FTP'd the driver file from a Windows system where I downloaded it to the OpenVMS system, and then I had to reset the file attributes. And at some point decades ago, we figured out what you had to do to reset the file attributes. We wrote it down, and I include it because then I know where to look the next time I need to do it. A bit of a sidetrack about Java versions. On Alpha OpenVMS version 8.4, the newest Java version is the 1.5. For working on Alpha, this is actually a limiting factor because newer database versions, the JDBC drivers require newer versions of Java than 1.5. And so there are limitations onto what you can replicate from an alpha just because of the Java version. On Itanium, we're using Java runtime environment. We actually have multiple JREs. And in this case, we're using the most recent version of Java from VSI. So I mentioned an options file. We have a utility to generate the options file. It's called create LogMiner opt file. Excuse me. An options file only needs to be regenerated when tables are added. This is just a list of files that gets passed to the RMU_onload/after command, and you might need to edit it if there's a table that you don't want to try to send the data. In this example, I have commented out the resumes table from the personnel database because the resumes table contains a segmented string column, and RMU_onload/after doesn't extract segmented string columns. The other control files, we have a procedure that will create them called LML create control file. And this will create individual files. In this example, I'm going to create 3 different files. The personnel, MF personnel table.ini file, which describes the source data, the source tables. If you alter a table and add a column, for example, you're going to have to regenerate the table ini file. It's also a map table. So the table INI file describes the source data. The map table describes the mapping to the target. And we also generate a date filter file, which is really a template configuration file. And the reason we do this is that we've run into a number of applications where they did funky things with their dates and had dates stored in their RDB database that did not translate to the target. So what do these look like? In this case, the table.ini file. This is the data for the candidates table in the source database, and there will be a set of fields like this of lines for each of the tables. This contains information that was extracted from the RDB dollar relation field system tables, and we use it to interpret the data that we get out of the RMU unload/after. This is, if you really know what you're doing, you could edit this, but you really don't want to edit this by hand. You want to regenerate it. So that describes the table INI, describes source data. The map table describes the mapping to the target, and this you may need to edit just because of things like the map key. So as an example, the employees table, we have a number of columns, and one of the important notes here is that there was a primary key constraint, and so the map key, the column we're going to use to connect to the target data, is the employee ID, which is the primary key in this table. In RDB databases, not everybody has defined primary keys, so our utilities will assume a couple of things. One possibility is shown here, where the map key is originating DB key. And for this to work, you would have to add a column originating DB key in the target table. And this is a value that we get out of the RMU unload command that is the pointer, essentially the database key, the RD database key for the original record. In the case of job history, there isn't a primary key or unique index in the source database. And so because I've worked with the data, I've edited it and said that the key that we're going to use is the combination of employee ID and job start. If you know what the primary keys are for your data, this is relatively easy. If you've got them all defined in the source database, this is easy. If you don't actually know what the primary keys are for some of your tables, then this is going to require a bit of research and work. So the map table you often will need to edit, in particular to correct primary key specification. We generate this based on a key constraint or a unique constraint, or if none of the above, we add originating DB key. I mentioned originating DB key. It's an 8-byte integer in the target database. In the source database, it's a physical address of the source record. One thing about originating DB key is if you do something like reorganize the source database, then that's going to change the location, and so originating DB key will no longer be an accurate pointer for the data. I mentioned the date filter file. It's an example that we generate for every date. You don't have to use this, but we found it useful because we've run across code. The VMS date data type supports dates well past the year 9,999. The problem is that date formatting functions support 4-digit years. And for JDBC, essentially we translate the binary date into a character string date using the formatting functions. And so if the date was greater than the year 9,999, we can't generate a good character string date. So you've got the files to describe the source data, the files to describe the map into the target data. You need a command procedure that sets up some environment things and invokes the procedure JCC run CLM LML with 3 parameters: the source database, the options file, and a configuration file that points to the other configuration files that we're going to use. Looks something like this. We've got some other things in there where I've added some Java command line information to increase memory usage in Java and so on. It basically sets up some logical names, a logical name to control the checkpoint file. That gets used for restarting to make sure we can restart exactly where we left off. And then there's a configuration file, and this is where it gets different for each database. And since this is too small to read, I will pull out different pieces. In particular, the complication with every JDBC target is figuring out the connection string. So in this case, I'm using JDBC Oracle thin, which I got from the Rdb from the Oracle JDBC documentation. The rest of the connection string came from the cloud interface, the database connection button. So I copied and pasted 2 changes I made. I reduced the retry count from 20 to 10, and I had a good reason for doing it at the time, which I don't remember. And in this example, the service name is not the actual service name. So for security reasons, I replaced the service name that I was using with the service name in angle brackets. So I got the connection string off of the cloud interface where it said database connection. Driver and class path is the driver specification is from the Oracle webpage, and for every JDBC target, there's going to be documentation someplace that looks something like this. The class path is a mapping of the VMS device and directory tree, except instead of square brackets, I'm using slashes. So this is just the pointer to the driver on my VMS system. Once I get everything set up, I kick this thing off the batch and create a log file in my local directory. As it starts up, I gave the loader session the original name of KWH_O23AI. And so as the loader session starts up, it creates a control process that monitors the other things. It sets up a CLM process to do the RMU unload/after, and sets up a process to write to the target, a LML process. In this case, there may be cases where I want to have multiple concurrent threads writing to the target. And so I set it up to handle that, although in this case I only have one thread, and that's the 2 vertical bars and then the numeric 0. So what's this look like? Well, in one window, I connected to the database using SQL Plus, do a selection of everything from colleges, and there was nothing there. On the RDB side, I did what we call a no change update. So I updated the colleges and said city equal city, so the result was exactly the same as it was before, but what this did is it caused all of the college rows to be written to the after-image journal. I committed on the RDB database, and then seconds later, I did a select star from colleges on the Oracle database, and it was all there. So worked once, it's going to work every time. And I could do a lot more updates, and it's kind of fun to do thousands and thousands of updates and see them all appear, but it's not going to be particularly interesting in a presentation. The tools create a number of log files. In this case, there's the main command procedure that I submitted to batch, which the command procedure was mfp underscore oracle 23ai.log.com, and so the log file is mfp underscore oracle 23ai.log. There'll be a log file for the CLM process, the continuous log miner process, and in this case, a single log file for the LML process. The process is actually connecting to the target database with JDBC. If I had multiple threads running concurrently, then I could have multiple log files. And these contain various different information about what's happening. And a lot of times, don't have to look at them, but when there's an exception, you have to start looking and finding the first exception in a log file and then figuring out why that happened. If you're working with us at JCC for support, we will usually ask for all of the logs because we need to see all the details to figure out where there were issues. All right, so you got everything up and running. How do you tell that how quickly it's running? We have a utility, JCC LML Statistics, which strangely enough shows you some statistics. And there's a couple of parameters. In this case, the my loader session name, which is kwh underscore O23AI. I'm going to refresh the screen every 5 seconds, and I'm going to look at detail. And so it looks something like this. In this case, the input side is trailing by 0.09 seconds, so less than a second. We've done 9,800 transactions and so on. On the output, we're about half a second behind, and so on. And in the next slide, I'll look at this in more detail. But one of the things is that we're applying data to the target at 131% of the rate that it was applied to the source data. So we're a smidge behind, but we're keeping up pretty well. So we've done 9,800 transactions, a total of 49,000 records. So this is a toy example, it's not a real example. We've done 437 checkpoints on the target and have sent just under 40,000 rows to the target. In the bottom right, there is this detail of what's going on. And as I said, we're at 131%, at least for the last transaction. In this example, we are spending about 75% of our time waiting for input and 25% waiting for the target. Whenever we're looking at performance, one of the things we're going to do is to look and see how much time we're spending waiting for the target. And if we're spending 90+% of our time waiting for the target, that means that any performance issue is something somewhere on the target or somewhere in the network. But in this case, we're pretty close to real time. We can shut things down. When we shut things down, there is a restart information. In this case, we have written it to a checkpoint file. And in this checkpoint file, we have all the information we need to pass to the RMU unload/after command to restart where the shutdown occurred. Now, there are occasions where a restart may send some transactions that had been sent before, and there's a whole variety of timing issues there that we could go into offline. But the point is that we have the information such that we can guarantee that if nothing else gets broken, the source data has been continuously replicated to the target. And so everything that was committed in the source will be committed in the target. We can view the restart information. In this case, I'm doing an ARM JCC LML dump checkpoint, and the information includes the loader name, the start time and commit time of the last transaction that was sent, the transaction sequence number, the loader sequence number, which is an internal counter that we maintain, and something called the AERCP, which as a quiz later, you can figure out what AERCP stands for, but it's the information that we pass to the RMU command to tell it where to restart in the sequence of AIJ files. So once you have the data in an Oracle database, what can you do with it? Oracle 23AI implements parts of the SQL PGQ standard, which is of interest to me because I've been involved in the standards development and have been working on and in and around the work in the standards community to define a property graph query language to sit on top of SQL tables. So PGQ does two things. One is it allows you to create a property graph view on top of SQL tables, and it allows you to query it using a graph table function in an SQL from clause. So it allows you to do property graph queries on SQL data, which is an interesting capability for exploring and understanding and analyzing data. So in this example, I might create a property graph view where I have employees and jobs and some various properties, and I create edges, relationships between those, and define the edges and so on. And this details of the syntax are beyond the time we have here, but if you see me later, I'll be happy to go into more detail. The important thing about this is that it allows me to do queries without having to know what the relationships are between the data. In an SQL query, when I join two tables, I have to include the relationship. If I've got a property graph view on SQL tables, the property graph view contains the relationship and I don't have to specify it. I can query it. I don't have to know what it is when I'm writing the query. So this is a quick example of doing a query, including the property graph query in an SQL query. So when you're creating the property graph views, you have to understand the data and the relationships, but when you're writing the queries, you don't. You can query the relationship. And there's a lot of capabilities here. It's beyond the scope of this presentation. Okay, so RDB targets are fairly straightforward. The Oracle call interface is very powerful, but it's limited. And I believe with the Oracle call interface version that's available on VMS, the latest you can go as a target is Oracle 19. JDBC gives you a lot more flexibility. You have to have the correct version of Java on the OpenVMS system, and then you download the appropriate JDBC driver files, do a reset of the characteristics, and a little bit of additional work. We also can talk to Kafka. That's a whole nother topic, but basically we can publish committed transactions, RDB transactions, to Kafka, and then it's up to you what you do with it. So this is just another JDBC target. If you look at the set of presentations we've done in various forums over the last couple of years, when we're talking JDBC, this presentation is not hugely different from other presentations we've given. The complications here were navigating the cloud interface the first time to get all of the Oracle Cloud stuff set up. And then there was a relatively complicated JDBC connection string. However, we got all of that connection string from the Oracle Cloud interface. It was just a matter of doing a copy and paste. In this case, we're using the Titanium VMS with the latest version of Java that's available from VMS Software Inc. If we were to get a version of RDB on x86 VMS, then this would look pretty much the same from RDB on x86. And the fun thing about Oracle 23 AI, from my point of view, is the ability to do property graph queries. If you want to learn more, please contact us at JCC through our website or through info@jcc, or download the documentation. Any questions? And I mentioned additional stuff, which I've included in the slides, with some data type, possible data type conversions between RDB and Oracle 23. Timestamps are something to pay particular attention to. And we've got a number of other topics for filtering and transforming and so on that may be of interest in particular environments. Thank you.